Hello, and welcome back to Lecture 3, Organic Molecules and Structures. Please subscribe, comment, like, and share on my YouTube channel. Today, we will talk about structural formulas. What are structural formulas? What are the different types of structural formulas? Structural formulas are graphical representation of the molecular structure of a chemical compound, showing how atoms are arranged and bonded together within the molecule. A structural formula expresses how atoms are arranged in the molecule of a given compound. Each molecule is represented by a structure that shows how the atoms bond together. These formulas provide more information than simple molecular formulas, which only indicate the types and numbers of the atoms present. Structural formulas illustrate the connectivity between atoms and can also show the spatial arrangement of the atoms in three-dimensional space. Organic chemists use a variety of formats to write structural formulas. Here are some key types and features of structural formulas. We have a ball and stick model. For ball and stick model, which is the A, these formulas specifically represent the spatial arrangement of atoms in a molecule. It is also known as three-dimensional structure, that's 3D model. 3D models can be drawn through a variety of conventions, including wedge and dash notation, which indicate how bonds are oriented in 3 dimensions. The chains of atoms in the ball and stick model, which more accurately represent the actual shape of the molecule. So the first one is the ball and stick model. The black round color here represents carbon, and the red represents oxygen, and then the white represents hydrogen. Our second type of structure formula is electron dot formula. It is also referred to as Lewis structures. These illustrate the bonding between the molecule. Thus, these illustrate the bonding between a molecule's atoms and lone pairs of electrons. Each dot symbolizes an electron. So we can see from this structure, each dot represents an electron that is covalently shared. Yeah, that is covalently shared. And our third structure is dash formula. For dash formulas, it includes elemental symbols for all of the atoms in a molecule, as well as lines depicting bonding electron pairs. So we can see from the dash formula, each line represents a shade of electrons. And our third structure is condensed structure formulas. Condensed structure formulas contain the same information as full structure formulas, but in a more compact format. They depict the atom sequence rather than each bond. For example, propanol has the condensed formula CH3, CH2, Ca2, So this is an example of structure formula. Then the last type of structure formula is bond line formula. Organic chemists mostly use bond line formulas, also known as skeletal formulas. In these formulas, carbon atoms are represented by the ends and intersection of lines. For the sake of simplicity, hydrogen atoms that are attached to carbons are typically left out. So you can see from the line here, although it has hydrogen atoms, but you cannot see. Each line represents a bond, and each bend in a line representing a carbon atoms are included in the rules for drawing bond line formulas, unless another group is explicitly indicated. In condensed formulas, all hydrogen atoms attached to a particular atoms are usually written immediately after the carbon. For example, suppose we have a molecule with a molecular formula C5H12O. The structure formula can be written as we can see three structures. We have 1 pentanol, 2 pentanol, and 3 pentanol. They are all alcohols. So we can see this type of structure is dash formula. So we can see the first one, OH, is on the first carbon, and then the second structure, OH, is on the second carbon, and then OH is on the third carbon, as we can see from the third structure. The structure shows that 4 additional atoms surround each carbon atom. So if you look at these carbon atoms, it has 4 bonds. 1, 2, 3, 4. So carbon supposed to have 4 bonds. The structure can be condensed as, for the first structure, we can see that this is the carbon. So in the condensed form, we can have this carbon is having 4 bonds. So one is hydrogen. So it has 2, it does 2 hydrogen and 1 OH. So CH2, CH2. This is the H2, 1, 2. And then the OH will come. And then it is being bonded to other carbon. This carbon is having 2 hydrogens, so CH2. So this is the Ca2. And then this carbon 2, Ca2, another carbon, Ca2. And then the last carbon is being surrounded by 3 hydrogens. So that's CH3. The same thing refers to the second structure. The first carbon is surrounded by 3 hydrogens, so Ca3. The second is surrounded by 1 hydrogen and 1 OH, so CH and then OH. The third is being surrounded by 2 hydrogens, and then the fourth, 2 hydrogens, and then the last is being surrounded by 3 hydrogens. Then the last structure, we can see that's the 3 pentanol. Its condensed formula will have, that's the first carbon is surrounded by 3 hydrogens, and then the second 2 hydrogen. The third is having 1 hydrogen, 1 OH. So this is 1 hydrogen, 1 OH, and then the fourth 2 hydrogens, and then the last structure is surrounded by 3 hydrogens. A substance structure formula, like its molecular formula, specifies the precise number of atoms of each element per molecule. In addition, the structure formula depicts how the atoms are bonded together. As a result, the structure formula is critical for determining molecular shape and properties associated with specific molecular geometric arrangements. So we have an example here. Write a condensed formula. Write a condensed structure formula for the compound that follows. So here we can see ball and stick model. At the same time, we can see that the dash formula. So for the first structure, they are all mean the same. So that is 2 pentane. That's 2 meter pentane. 1, 2, 3, 4. Sorry. So here is 1, 2, 3, 4. That's the longest carbon chain. 1, 2, 3, 4. So butane, and then this one is the meter group. So the meter is being attached to carbon 2. So 2 meter butane. The same thing. 1, 2, 3, 4. That's our longest chain. So this is the methyl group. So that's 2-methyl butane. So the first structure is that's 2-methyl butane. So how do we write the condensed formula for this structure? So the condensed formula can be written as the first one, the black represent carbon. So we will write our carbon here. So let me select our good. So for the first one, we will have our carbon here. And then it is being surrounded by 3 hydrogens. So our hydrogen will be 3. And then our second carbon will come. It is being surrounded by 2 hydrogen. One is hidden, and then the methyl group. And then the third one is being surrounded by 2 hydrogen. So third carbon, this is 2 hydrogen, then the last one, 3 hydrogen. So we can see from the Dutch formula, first carbon is being surrounded by 3 hydrogen, that's CH3. So that's the CH3 here. The first one, this carbon is this one. So it being surrounded by 3 hydrogen. Then the second one here is being surrounded by 1 hydrogen and then 1 methyl group. So 1 hydrogen and 1 methyl group. And then the third one is being surrounded by 2 hydrogen. So this is the 2 hydrogen and then the last 3 hydrogen. So this completes our condensed formula for 2-methyl butane. For the last structure, it can be named as 2, 3, 4 trimethyl pentane. That's 2, 3, 4 trimethyl pentane. So the condensed formula can be written as for the first carbon, it being surrounded by 3 hydrogen. So CH3. Our second carbon is being surrounded by 1 hydrogen and 1 methyl group. So CH3. And then our third one is being surrounded by 1 hydrogen and 1 methyl group. So carbon. And then the fourth one too. And then the last one, CH3. So this completes our structure formulas. Thank you. This is the end of lecture 3. Please subscribe to my YouTube channel, Prince Owusu Achaw at Weniswakem. You can reach me on email prince.owusuachaw@yahoo.com or through LinkedIn, Prince Owusu Achaw. Thank you.